Hi everyone, we're on trigonometry and we are going to look at deriving the famous formula they call the cosine rule. We use this rule, the cosine rule, is when you are given a triangle and you have some features of the triangle that are missing, maybe one of the angles and two sides are missing, and then you are asked to find the two remaining angles, or the sides are given, then they ask you to find the angles, or the angles are given, they ask you to calculate the sides of the triangle. So this is where the cosine rule comes in. But before we jump into deriving the cosine rule, let us refresh our memory with the trig identities, the 3 or 6 trig identities that we have. If we have this triangle, for example, 90 degrees here, A, B, C. So you know, if we are taking this angle, for example, angle A, so angle A, this is its opposite side, this is its hypotenuse side, and this side is adjacent to angle A, this is the adjacent side. This is B, don't forget. So you want to find the sine of angle A. So sine of A will give you the opposite side all over the hypotenuse side. If you want to find the cosine of angle B, just say cos B, cos A, sorry. This is the adjacent side divided by the hypotenuse side. If you want to find the tangents of angle A, we abbreviate by tan of A. This is the opposite of angle A, which is opposite all over the adjacent of angle A. These are the 3 identities. Of course, if now you flip over opposite, hypotenuse upon opposite, you get secant, you get secant, you get cosecant, secant, and cotangent. When this is now 1 all over sine of A, you get cosecant of A, cosec of A, and this one will be sec of A, and this one will be cotangent of A. But these 3 are the most important ones anyway. Correct. We know this already. So now, but these formulas here, sine A opposite upon hypotenuse, cos adjacent upon hypotenuse, tangents opposite upon adjacent, are only applicable when one of the angles in the triangle is 90 degrees. Suppose now you have something like this. Let me draw it. Let me have a better diagram. And here you have A, B, C. Now, all these angles here are each is less than 90 degrees. So suppose now you have a triangle like this, and you are given these 2 sides, and given this angle here, then they ask you to find the remaining missing features in the triangle. So what do? You cannot apply this rule, because this rule is only applicable when one of the angles is 90 degrees. There is no 90 degrees there, so you don't apply these ones. That is why the cosine rule and the sine rule comes in. But today we are just going to do the cosine rule. We shall come to the sine rule later on. So what do? As you know, in mathematics we always manipulate. So we come here, we try to form a triangle, a right angle triangle inside this triangle. So we cut it from here. So we have now formed two triangles here. If you split this whole triangle into two, you'll get one here and the other one here. So this line now, we'll label it by letter H. We'll label it by letter H. So, I hope you understand what you have done here. This is one triangle. These are two triangles now in one. So if you are looking now, and I want to put N here. And you know, in trigonometry, if you have the angle here, the side that is opposite to this angle, if this is letter A, this side will be small capital A. C, big C, capital C here, so the side opposite will be small c. And also B here, so this whole length is B. This whole length is B. If this whole length is B, what is this and what is this? We don't know. So I want to put an X here. That is from this one to this side. I say it's X. Just to simplify things. And then from here to here, I can now say this will be B minus X. This length now will be B minus X. So if you add B minus X plus X, you get B, which is B here. Because this whole length, this length of this line has to be B. This whole length has to be C. This has to be A. So this is what you have. So now, we have covered a powerful formula or theorem called the Pythagoras theorem. I now want to apply the Pythagoras theorem here. We know it, we can state it, we know what it means, we can just use it directly. Any triangle, the hypotenuse, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So in this triangle now, let me start with the big one. We have triangle ABN, that is this one, this one, this one. You have the hypotenuse, as we see from Pythagoras, c squared is equals to the sum of the other remaining sides. Must be equals to h squared plus x squared. Looking at this triangle, you have c squared equals to h squared plus h squared. So, we want to find what h is. So now c squared minus x squared must be equals to h squared. Let's stop there. Again, let's look at triangle BNCBN. BCN. Looking at C, you have now the hypotenuse on this, which is A, which is a squared. You're still applying Pythagoras theorem, and it's equals to h squared, the adjacent, plus b minus x all squared. This is the adjacent squared plus opposite squared must be equal to the hypotenuse squared. So again, here, what is h? We now have a squared minus b minus x all squared equals h squared. We have h squared from this triangle giving us this one, and we have the same h squared from the other triangle giving us this function. It means what we have here on the right hand side must be equal to what we have here on the right hand side, because the the same h here. So we can be able to state that c squared minus x squared must be equals to a squared minus b minus x all squared. We can state that because both equations are equal to the same unknown. So if that is the case, we can now expand this function we have here. Expand this. If we expand this, you get c squared minus x squared equals a squared minus, I will put the bracket for now, b squared minus 2bx plus x squared. That's what you get. But now I want to remove the bracket sign, so this will go to plus and this will go to minus. So the bracket sign is no longer there. Correct? So if that is the case, you have minus x squared, so the x's will go. So you now have, I can remove this one now. We now know what is this one. So I can remove this side. So we now have c squared equals a squared minus b squared plus 2bx. But what is x? We don't know what x is. We don't know what x is. Why do we have minus c squared? Oh, sorry. I made a mistake here. You have this is the hypotenuse c squared plus 2. Which one are you looking at? ABN. You have c equals h plus x. You have, yeah, that's correct. Yeah, that's correct. I'm just looking at what I'm having minus b, where this is, you have here again h squared 1 equals to a squared minus this. Okay, so let's continue. Now I want to find why am I having b squared minus b? But this sign minus. Why is it minus? Where have I gone? b minus x. Let's see how far it goes. So what is x here? A, B. If you look here, correct. Now I see. Fine. I want positive numbers here. Yeah. So what I'm gonna do, a squared plus b squared minus 2bc. And still. Okay, first let's work out what is b. This b and x. B and x. So now, if we now have the cosine, we want to find the cosine of A, yeah? So we can either find the cosine of A, the cosine of C, because this angle now, we can't find the cosine of this B. So it's either A or C. So because C has X and I see X here, sorry, A has X here and I see X here, so let's find the cosine of A. So we know cosine of A is equals to the adjacent all over the hypotenuse. So the adjacent, which is x, all over the hypotenuse, which is c. That's cos A. So this gives you c cosine of A equals x. So which means this x can be now represented by c cos A. So you now have from this equation here, from equation 1, you now have c squared equals a squared minus b squared plus 2bx. Instead of x, we now have c cosine of A, 2bc. It's A. So this is, we now want A. So we want A. Because we have cos A here, let me write this properly. So you now have c squared equals to a squared minus b squared plus 2bc cosine of A. So because we have cosine of A here, we want the letter on the other side, on the left hand side, to be the side A. Because we have cos A, we want, instead of C here, we want A to be here. So it's going to be A equals everything on the right hand side. Yeah? So for that to happen, we now need to bring everything here on the left hand side. So we already have C squared is now going to be this minus, it's now going to be plus B squared. So this is plus now, it's now going to be minus 2bc cosine of A. And all this now is equals to A, right? All this is equals to A squared. I hope you understand. Transpose. Just bring everything on the right hand side, left hand side. We leave A on the right hand side. This is what we have done. So we have c squared plus b squared. Why can't we say b squared plus c squared? So you now have here A squared is equals to b squared plus c squared minus 2bc cosine of A. We have derived the cosine rule. This is the cosine rule. This is a powerful formula. So A squared equals b squared plus c squared minus 2bc. What you have here, bc, b squared, c squared. So what you're going to have here, minus 2bc. And now the cosine will be this the side opposite the angle A. I hope you can see the relationship here. So what we do to get b squared and c squared, can I take off this one now? So we take off this.
I want to play with jackets.
Okay, come. Right? We have this formula here. A squared equals to b squared plus c squared minus 2bc, the cosine of A. If I now change these letters, I bring A here, and I bring C here, then I bring B over here, and I leave everything the same. What will change?
No.
What is going to change? This formula is going to change. We are not going to manipulate this because what we want here, whatever the cosine is here, the capital letter here, we want its small letter at the front. So by doing that, you just change again the letters in those positions. So we now have b squared must be equals to a squared plus c squared minus 2ac, the cosine of b. We now have c squared must be equals to a squared plus b squared minus 2ab, the cosine of c. These are the three formulas you get for the cosine rule. Can you see the relationship? If it is c squared you have a squared b squared minus 2ab cos c. b squared a squared c minus 2ac cosine of b. This is what you have. You just need to know one. The rest, there is a strong relationship between them. So when you know one, then the other ones will just come up. So now we have these formulas. How do we use them? In another video, we shall solve problems on using the cosine rule. Thank you for watching. Bye bye.